is going to be like what I said. We're moving away from perfect squares, and we're getting into what are called irrational numbers. Everybody say irrational numbers. What's the opposite of an irrational number? A rational number, right? So everything we've been dealing with has been a rational number. Irrational numbers are just the opposite. It's basically a number that can't be simplified all the way to where we just get a number, right? If you'll notice my examples, were there any square root symbols in any of my answers last week? No. I just had a fraction, I had a negative number, I had a negative fraction, a plus or minus fraction, right? But there's no square root in my answers. So today, we're going to start out with something that's a little bit easier, estimating square roots. If I'm estimating something, what does that mean? Rounding. Good. What else does estimating mean? Approximate answer, right? Is it an exact answer?
No.
Do I know that my answer is going to be exactly 3? No. I'm going to find a range of answers that it could be by using our perfect square chart. So we're going to find approximate square roots by identifying which two perfect squares the given number falls between. Go ahead and highlight that real quick. So if I give you a question like this, right, the square root of 18. If I look back on my perfect square chart, is there the square root of 18 listed anywhere on here? No, because 18 is not a perfect square. I've got 1, 4, 9. You guys okay, Eva? Yeah? Okay. 1, 4, 9, 16, 25. There's no 18 on there at all. So I need to find where 18 falls in between. Which perfect square is the closest to 18, would you say?
4.
Probably 16, right? Is 18 more than 16 or less than 16? 18 is more than 16. So the square root of 18 is going to be somewhere in between 16 and 25. Everybody get that so far? Yeah? Well, what's the square root of 16? 4. And what's the square root of 25? 5. So if the square root of 18 is somewhere between the square root of 16 and the square root of 25, then my answer is going to be somewhere between 4 and 5. Right, if I take out a calculator here, and I do the square root, if I take 18 and try and find the square root, what do I get as an answer? 4.24. What two whole numbers is 4.24 in between? 4 and 5, right? So we're not finding this exact decimal answer. I don't care about that. I know you can plug that in a calculator. I want to see if you're able to figure out the range of answers I could have, right? So the square root of 18, it's a little bit more than 16, a little bit less than 25. It's going to be somewhere in between 4 and 5. Does that sound okay? Does that make sense? Kind of? No? What about square root of 68? What's the closest perfect square here to 68? Probably 64. Is it more than 64 or less than 64? More than 64. So it's going to be slightly more than 8, but it's definitely going to be less than 9. So the square root of 68 is between the perfect squares 64 and 81. Well, the square root of 64 is 8, and the square root of 81 is 9. So my answer is going to be between 8 and 9. Quick show of thumbs, how we're feeling about figuring that out. Just using our chart, finding where it falls between. Yeah? Okay. I appreciate those of you that are, keeping up, following along. If I was going to estimate these ones, right? Square root of 6. What's the closest perfect square to 6 here? These yellow numbers is what we're looking at. What's the closest to 6? Probably 4. Is it more than 4 or less than 4? More. So see how The square root of 5, the square root of 6, the square root of 7, the square root of 8 are all going to be in between here, in between these two. Rhea? Stuff or no? No? Okay. Where am I looking? Oh, I went the wrong way. So the square root of 6 is going to be in between the square root of 4 and in between the square root of 9. So what would the root of 6 be in between? What are my two pink numbers there? 2 and 3. So this is between 2 and 3. That's my answer. We're not looking for an exact answer. We're estimating. Like Jawad said, it's an approximation. It's not quite the exact answer. But we know where our answer is going to fall between 2 and 3. What about square root of 90? What's the closest perfect square to 90? If I'm looking at my chart. Probably 81, right? Yeah, great job. Thank you, Alyssa. 81. Is it more than 81 or less than 81? More, okay, so it's going to be in between here. What's my answer going to be if I fall in between these two boxes? Between 9 and 10. Give the next 4 a try. See if you can use your perfect square chart to find where those imperfect squares per se fall between. Should take, 60 seconds. It'll be quick. Yeah. Read out here. You're welcome. You should watch the video with those two. Yeah, the trends down what we're doing right now. Nice. Good job. Perfect. So this one between 5 and 6. Let's put back the chart real quick. So 5 and 6 are 25 to 36. So 26, 27, 28, 29, 30, 31, all those numbers, right? 21, does that fall in that range? Yes, it'll be in between 16 and 25. Right? Because 16, 17, 18, 19, 20, 21. Oh, 21. That's what it's going to be. So between 4 and 5. Good. This is 7 and 3. Let's say 3 and 10. So the numbers should be next to each other. 1, 2, 3, 4, 5. So 300 is in between 289 and 324. So your answer is between 17. All right, 21. What's the closest perfect square would you say to 21 here? Probably 25, right? Is 21 more than 25 or less than 25? It's less. So we've got to look backwards, right? 21 is going to be in between 16 and 25. So the square root of 21 is going to be in between what? 4 and 5. Right? We're using the roots as our answer, not the squares between 4 and 5. What about 300? What's the closest perfect square to 300? Probably 289. Is it more than 289 or less? More. So it's going to be slightly more than 17. Not as big as 18 though. It's going to be somewhere between 17 and 18. You guys got both those so far? 3 and 4? Yeah? Okay, what about 42? Closest perfect square to 42? Probably 49. It's a little bit less. It's more than 36, less than 49. It's got to be somewhere between 6 and 7. And what about 75? Yeah, Alicia. Yeah. What about 6 and 7? 75.
8 and 9.
Yeah, between 8 and 9. So it's close to 64, close to 81. It's in between 8 and 9. Go. Okay, give me a thumbs up. You got all those right. Anybody? Okay. Pretty easy, right? Yeah. All right. So perfect squares, they're all rational numbers, but not every number is going to be rational. Sometimes we got to just pull out what we can and leave behind what doesn't have a pair. So if I have the square root of 12, okay, you guys have all made factor trees before. Let's make a factor tree for 12. What two numbers multiply to give me 12? Oscar, what two numbers? 6 and 2. Perfect. We can do 3 and 4. Doesn't matter. What two numbers multiply to give me 6? 3 and 2. We've done this in this class before, haven't we? Yeah. Okay. So 12, if I were to break 12 down, it's just 3 times 2 times 2, or 2 times 2 times 3. Okay. Now this is where it's a little bit different than what we talked about before. Do I have any identical pairs of factors inside that square root? Yeah, what's my pair of numbers? 2. So I'm going to circle up my pair of 2's. I'm going to bring them out in front of the square root where they come together and become one singular 2. Is there any number that didn't have a pair to jump out of there with? Yeah. So what do you think happens to the 3? It stays behind inside the square root sign. Plus or minus in front, as always. And that's my kind of weird looking answer. Plus or minus 2 times the square root of 3. So since 12 is not a perfect square, we can just break it down as much as we can. Anything we can pull out, we'll pull out. Anything we can't pull out gets left behind. That's really all it is. Which makes this number 2 root 3 an irrational number. Because we cannot write it as a fraction. We're not going to worry too much about like definitions and stuff like that. We're just going to focus on breaking everything down and simplifying as much as possible. Okay, notice right, nice big bold on the top of these two. Estimating square roots versus simplifying square roots. So when we get the test in like 2 weeks and the question is square root of 12, if it tells you to estimate it, there's one thing you're going to do. If it tells you to simplify it, it's a completely different process. So you have to be able to know the difference between the two. Does that make sense? Yeah? Okay. Square root of 18. Let's do a little factor tree here for 18. What two numbers multiply to give me 18? 2 and 9. We can do 6 and 3. I'm going to do 2 and 9. What two numbers multiply to give me 9? 3 and 3. Anything else I can split up? Nope. So now I've got 2 times 3 times 3. Everybody with that so far? Yeah? Yes. Do I have any pairs I can circle up and bring out? 3. Yep, pair of 3s. Is there anything that gets left behind? The 2. So what's my answer going to be? 2 inside, 3 outside. Okay, what's going to be the very first thing we write? Plus or minus, thank you. Plus or minus, what? 2? The 3 came out, right? 3, then what? Little thingy, yep. 3 root, what? 2. It's going to take a while to get used to seeing answers like this just because it's something new and it's a little bit weird. But the more practice we have, the more sense it'll make, right? Any questions I could answer about that first one? Let's take a look at 24. Let's do a little factor tree for 24. What two numbers would multiply and equal 24? We could do 6 and, so say 6 and 12. Oh, 6 and 2. Or no, 6 and 4, 2 and 12. I'm going to do 6 and 4. What two numbers multiply to give me 6? 3 and 2. What about 4? 2 and 2. So I've got 2 times 2 times 2 times 3. Those are all my prime factors for 24. Looking for pairs. Do I have any pairs I can circle up here? Yeah. Should I circle up 2 of them or all 3? Just the 2. I'm only looking for pairs. That pair of 2s comes out. Right? Does this 2 have a partner to leave with? Nope. It's all alone. Does this 3 have a partner to leave with? No. So they've got to stay behind. So just like before, we're going to start with plus or minus. We brought out the pair of 2s. That's going to become a singular 2. We didn't bring out everything, so there's going to be a square root left over. And what's going to be inside the square root? How'd you get 6? 3 times 2. We just bring those remaining terms back together, which gives me 6. Plus or minus 2 root 6 is my answer. Is that making sense a little bit? Maybe? Okay. What if there's 2 pairs? Great question. Is that going to happen here? No, I don't think so.
Yeah.
For 40? Well, 40 is 4 times 10, so 2 times 2 times 2 times 5. It'll be the same thing as this. Let's change 40 into...
I thought it was 2 times 2 times 5 times 5.
Yeah.
2 times 2 times 5 times 5? Well, 10 would be 5 plus 5. But 10 is 2 times 5. Yeah. Well, I'm going to change 40, because, yeah, that's a good point. I'm going to bring out 2. 16 times 2. Let's do 32. Change that 40 to a 32 real quick. Okay. 27. What two numbers multiply to give me 27? 3 times 9, or 3 times 3 times 3. Good. What can I circle up and bring out? 3 times 3. What gets left behind? That third little 3. I can only bring things out in pairs. I cannot bring out any triplets or anything like that. And finally, 32. What two numbers multiply to give me 32? 8 times 4. What two numbers multiply to give me 8? 2 times 4. What two numbers multiply to give me 4? 2 times 2. So I've got 1, 2, 3, 4, 5 2's. 2 times 2 times 2 times 2 times 2. You guys see that okay? Okay. This is a good one to bring up. I'm glad you brought this up. What pairs can I circle up here? I got a pair of 2's here, and I got another pair of 2's there. What's left behind? That fifth lonely 2. So now I've got 2 pairs that I'm bringing out, a pair of 2's and another pair of 2's. So these 2's fuse into 1, and these 2's fuse into 1. So what I have out here now is 2 times 2 root 2. Does that make sense? Kind of like whatever's left behind, we multiply it back together. If I bring multiple things out, I'm just multiplying them together. Well, what is 2 times 2? 4. Root 2. Obviously, don't forget your plus or minus sign down in front. We already know that, hopefully, so it's good. Now, look at all these answers. They all look relatively similar. But the questions that I started with, all very different numbers, right? So what we can bring out is important. What gets left behind or multiplied together and left behind is also super important when we're doing this stuff, okay? Remember, actually, do you guys have 2 highlighters? Real quick, go ahead and take them out. On the 4th note page, I want you to highlight estimating in yellow. And on the 5th note page, I want you to highlight simplifying in pink. It's up to you to make sure you're reading the directions and doing the right thing. Because if it says estimate the square roots and you start breaking out the factor trees, you're not doing the right thing. If it says simplifying square roots and you're looking back at your chart going, oh, it's between here and here, you're not doing the right thing. Estimating, just like how the word estimating sounds, is not an exact answer. Simplifying is exactly what we just did. Breaking it down, bringing out whatever we can, leaving behind whatever's left. That's the process of simplifying. All right, question?
How do you know the order in which way to put it?
This way? Like what order to put them? The answer?
Yeah.
Like how do I know the 3 goes on the outside, the 2 stays on the inside?
Yeah.
Well, was there a pair of 3's or a pair of 2's that we brought out?
3.
Pair of 3's, so 3's on the outside.
Oh.
Yeah, the pair, just like before, the pair gets brought out. But now what we have that's different is not everything is getting brought out. Something is getting left behind. It's whatever doesn't have a pair to break out with it. You know what I mean? Like I said last week, if this square root is a jail, these 2 3's are able to get together and break out, but this little 2 didn't have another 2 to break out with, so he's stuck in there. You know what I mean? Great question. Any other questions I can answer? Perfect. You guys feel okay with this?